So in this video, we're going to talk about dilution and what that simply means. So in most laboratories, all right, solutions are oftentimes stored in high concentrations, and just for cost savings, right? And so, you know, especially in my lab, I mean, the hydrochloric acid, sulfuric acid, these types of acids, I have very high concentrations in the stock room, all right? And anytime I need to use them, I take them out and then I'll go through a dilution process, all right? And so what does the dilution process entails? Well, it is basically decreasing the concentration. All right, that's what diluting is. It's you're decreasing the concentration of some solution. All right, so let's just kind of talk about some of the key points of this. The amount of solute remains the same. All right, so when you're comparing the concentrated solution to the diluted solution, the amount of solute you have remains the same. All right, it doesn't change. All right, what's the difference is the amount of solvent. So the difference is how much solvent you have. All right, that's what's the big thing there. All right, and so because the number of moles remains the same or remains constant, then we could use a simple equation to dilute. And the equation is MCVC equals MDVD. What does this mean? All right, so this means the molarity of the concentrated solution times the volume of the concentrated solution is equal to the molarity of the diluted solution times the volume of the diluted solution. All right, and so the equation could be rewritten in many different ways. All right, and so like for example, we could rewrite the equation to solve for the concentration of solution after dilution, right? And so in this case, it will be the molarity of diluted solution equals the molarity of the concentrated solution times the volume of the concentrated solution divided by the volume of the diluted solution. All right, and so from this we could come up with the dilution factor. Now the dilution factor is the ratio of the initial and final solution volumes. All right. Other words, it's the volume of the concentrated solution divided by the volume of the diluted solution. So that's your dilution factor. Okay, and that's all that simply means. All right, so let's kind of look at an example so that you can kind of see how we could use these equations. So what is the final concentration if 75 mils of a 3.5 molar glucose solution is diluted to a volume of 450 milliliters? Okay, so our overall equation is as such. So molarity of the concentrated times the volume of the concentrated solution divided, it's equal to the molarity of the diluted solution times the volume of the diluted solution. All right, and so let's kind of read through this problem so that we understand what we're doing. All right, and so it says, what is the final concentration? So what is the diluted concentration? So this is what we're looking for. If 75 mils of a 3.5 molar glucose solution is diluted to a volume of 450 milliliters. All right, and so I could clearly see already that this is the volume of the concentrated solution. This is the molarity of the concentrated solution. All right, so because it's telling you the 75 mils of a 3.5 molar glucose solution, and then it gets diluted to a volume of this much. So that's my VD here. Okay, so ultimately I'm looking for MD. So I'm just going to rearrange this equation so I can solve for MD. Once again, I did that. All right, so I have MD equals, or the diluted solution, the concentration of the diluted solution is equal to MC times VC over VD. Okay, and I'm gonna go ahead and put this in, and so I get 3.5 molar, all right, times 75 milliliters divided by 450 milliliters. So my units of milliliters cross out. I'm left with molarity. So when you plug this into the calculator, you get 0.58 molarity of glucose. All right. And so that is the new concentration once it gets diluted. Now, if we're looking for the dilution factor, all right, remember the dilution factor is just VC over VD. In this case, it's 75 over 450. All right, so that's our dilution factor, and it turns out our dilution factor is, so dilution factor is 0.16, or sometimes it may say 1 over 6, or 126. So I wrote 16 here. It's 1 to 6. All right, so that's the dilution factor for this question here. All right, so this is dilution.